The titration is 5 milliliters, and we're given the molarity of NaOH as 0.010 molar and of the titrant HCl of 0.005.
On the graph, the y-axis has pH and the x-axis is volume of the titrant.
So then you find the pH, and the equation is pH equals 14 minus pOH. So you plug in the molarity of our base, which is 0.01, and you get 12.
Then graph 12 on the pH scale, which shows a very basic solution.
When finding the pH of the titrant HCl, we know that HCl is a very strong acid, so we can just directly place it into pH minus log 0.005, and when we calculate that, we get pH of 2.3.
And when plotting this point on the graph, we put it very low because the pH is very acidic. When finding the stoichiometric point, you want the moles of the acid to equal the moles of the base.
When we have a strong acid and a strong base, the stoichiometric point is always pH of 7.
On the graph, the stoichiometric point is halfway between the pH of the initial base and the pH of the acid at 7.
When finding Na, we multiply the initial volume times the molarity of NaOH, which is 5 milliliters and 0.01 molar, and we get 0.05 millimoles.
Then we want to find the volume at the stoichiometric point, so we take the moles divided by the molarity, which is 0.05 millimoles divided by 0.005 moles per liter, and you get 10 milliliters.
So when finding the volume of the solution at the halfway stoichiometric point, you get the 1/2 of the number of moles of the base, and in this case it's 1/2 times 5 milliliters times 0.01 molar, and you get 0.025 millimoles.
To find the pH, you take 14 minus log of the moles you got in the last equation, which was 0.0025, and so you find the pH is a very basic solution at 11.402.
And lastly, your final graph should look a little bit like this.